So this is a problem that I got for presentation 3. So we want to find if H contains a zero vector of V, and for that we have the problem, right? And V equals R squared. We have that here, and 0 equals the 0 and 0 vector of R squared. So 0 times 0 is less than or equal to 0. So 0 vector is in H. For part 2, we want to find if H is closed under addition. So we let x1 and y1, x2 and y1 be the sum of H. So this is x1 and y1 less than or equal to 0 by the problem, and for x2 and y1 as well. Then we prove that the x1 y1 plus x2 and y2 equals x1 plus y1 and y plus y2. And we let then we want to find a value for the two vectors that will prove if it's open or closed. So by definition, this would be, we would know that this would be the result. So x1 and y1, we'll put that as -1 and 0, and x2 and y1 will put that as 0 and 2. Now if we change out the vectors, we'll see that we get -1 and 0 plus 0 and 2, and that'll give us a vector of -1 and 2. And with this, we see that H is not closed under addition, right? Because we will get if we add these two, the multiple, we will get -2, and that cannot equal to, or that is less than or equal to 0. So H is not closed under addition. And here's our vectors or values. For part 3 is we're going to find if is H closed under scalar multiplication. So we have x and y, the sum of H, and x and y is less than or equal to 0. We let 2, put a value of 2, x and y equals 2x and 2y, multiply that. So we would assume that 2x times 2y equals 2 squared equal x, y, and that'll be less than or equal to 0. However, it is obviously greater than 0, so H is closed under scalar multiplication. And for the fourth part, we want to find if H a subspace of R squared equals V. So for this, both H should be closed under both operations. So it should be closed under addition and multiplication. However, since we proved that it's not closed under addition, we know that H is not a subspace of V. And that's it for presentation 3. Thank you very much.